All right, I gotta repeat myself here now. Oh, well. So why are ethics important for psychological research? There you go. What do you think of some of those experiments yesterday? Oh boy, what were those guys thinking? All right, so why are ethics important for psychological research? What do we have here for this? What do we got for this here? Sarah, what do you have?
I said they're important because the people being used for the research are like the reason that psychologists get their data in the first place. So it's important to treat them like with respect and fairly. And also like permanent psychological damage can be inflicted upon them, and that's like kind of inhumane.
Yeah.
And it's unfair to the people who are offering their help for research.
Yeah, good job. So it's really up to the participants who are involved in your study to gather your data that you need, and putting them in harm's way is definitely not okay, right? It's not right to do. And many of the cases that you read about yesterday with the assignment kind of expresses that and shows that some of these psychologists pushed it too far. And some of these experiments maybe were very unethical because it put these people in harm's way. Either it was electrical shocks, right? Or it was maybe thinking these people were prisoners in a prison, and they actually took up these roles and thought they were prisoners or prison guards or the superintendent of a prison. Okay. So it could have some psychological damages of these people, not only physical damages. Confidentiality, right? Okay, that's one of the biggest things too that we need to focus on when we're performing these forms of research and psychological experiments, that even if we do perform a study and it might cross some of these ethical boundaries, that these people will be protected their whole life, and they won't be looked at weird if they go to the grocery store because of some of these reported findings and results of whatever these people might be testing. So yeah, ethics are very, very important. And across the years in the 1900s, right, this is kind of where these guidelines were established and set out to make sure that we can study these experiments and know right and wrong, what they did and what they performed. Okay, some of these experiments, although they crossed ethical boundaries and they are viewed as unethical, some of their findings actually were very, very, very useful, right? Okay, very beneficial to the study of psychology and sciences and maybe what the body can endure. But we need to really take care of and understand that these are people, right? That they have feelings, they have conscious awareness of where they're at, and how this could maybe damage them moving forward and the development and their life in the future. All right, good job. Is there any questions on that, ethics and research? We all know why that's important. Okay, we all know why that's important. All right, so the activity from yesterday, let's go over this real quick. Let me pull that up. So you had to read an article here that dealt with some of these experiments that crossed ethical boundaries and answer some of these questions that pertain to it. All right. So number one, describe the little Albert experiment. What was the hypothesis of this experiment? How is this experiment unethical? All right, Sarah, what do you have?
I said the hypothesis was that if association and reinforcement are connected, fear could be, I guess it's supposed to be generated by this, as opposed to adverse sexual experiences, which is what signifies.
Yeah.
And I said Albert was subjected to intentional psychological damage to learn about how fear develops in like young children. So basically, like with the rat, like the white rat, and the associating the frightening noises with that instilled like a fear in him at a young age, like light fuzzy objects. So that's kind of like could be a permanent thing that he would deal with the rest of his life for like psychology.
Yeah, good. So like created a phobia for little Albert, unfortunately, and how this caused some damages with him and created this fear that whenever he sees a rat probably ever again, he's deathly afraid of it. Okay. And he did this by having the baby sitting there, and he would just show the rat, right? He'd show the white rat there, and he'd make loud banging noises with many different types of things and many different types of, I guess you say, instruments. And the baby, obviously hearing the crashing, the loud noises, and seeing the rat, he would then write down, and his idea was, we're going to create a phobia of white rats to little Albert. And obviously that's pretty unethical. That poor baby couldn't imagine that. All right, so yeah, he was very fearful of this. I'm sure the rest of his life. I like to maybe research that a little bit more and see how that person maybe was affected by it, okay, and how that caused some issues for him. And yeah, that was an interesting study for sure. And just creating phobias for people reminds me of Scarecrow and the Batman movies. You ever see that? No? Anybody watch Batman? Batman Begins? Oh, he has a fear toxin. He injects it into people, and then like their deepest, darkest fear kind of, they hallucinate over it. It's pretty neat, actually. It's pretty cool. And that kind of reminds me of that every time I see that experiment or read about it or look over it. It's pretty funny. But yeah, phobias is created with children at a young age, especially like with a dog, a large dog. Let's say they get bit by it, or loud noises and crashing noises. Okay, we all know that. He wanted to try to maybe decide how we could focus his attention, his phobia on rats, right? If we maybe make these loud noises around him and try to trigger a phobia for him. So I thought that was interesting. Pretty unethical for little Albert. 2, how are the exceptions during the 1940s of ethics within research? What was the Nuremberg Code? Be specific. Campbell, what do you have for this one?
I see that there were exceptions because of war crimes because of World War II, so they were allowed to use the participants of the war. And then the Nuremberg Code was a set of guidelines for like how the treatment of live participants should be done and like regulations.
Yeah, good job, right? So especially with World War II, some of these Nazis experiments with their undesirable people, as they labeled them, and obviously communist Jews, different types of ethnic backgrounds and cultures, they would perform tests on these people. Some of them very shocking, seeing how the body can react in very cold temperatures. How they time to see how long that person could withstand very cold temperatures, and just time it to see how long the body can react to it. High altitude, same thing, until they need oxygen mask. So they take them up in an airplane without an oxygen mask, see how long they can last until eventually they would maybe become unconscious or maybe die of lack of air. And G-force, same thing with some of the jet planes that they were creating, how they can try to come up with different types of, I guess you could say, wardrobe guard to try to protect them from the G-force of jet planes. There's many different experiments, crazy experiments that were done, not only by the Nazis, Germans, but by the Japanese as well. Okay, and using some of these as reference, yeah, they actually did give off some great results and information of what the body can actually withstand, which very unethical to do. But some of the science that they got from it, it's a very touchy subject. It's like, oh, we can use this to maybe come up with different types of life vests or wardrobe or outfits to help these people out in these severe cold temperatures, or creating these different types of jet planes, how we can try to protect the human being in these elements. And yeah, they got some good information to help these people, but it came to a very, very costly cost, right? And how that was detrimental to many of these people, very unethical. All right, good job. Good job. Very interesting stuff. There's a lot of articles about some of these experiments and what was done to some of these people, and it was terrible stuff. But for sciences, they unfortunately saying they found a lot of information to help in these environments and these different situations and scenarios. All right, 3. What was Milgram's experiment? How did Stanley Milgram cross ethical codes within his experiment? Booker, what do you have? Yeah, good job, good job. So he would set up an experiment where he would try to see and understand with learning and cognitive development in a way, and he would have these people strapped to like an electric chair, okay, or just like electrodes attached to them, and he would ask them questions. If they got them right, okay, they wouldn't get shocked. If they got them wrong, they got shocked, okay. So he was trying to maybe, I guess, force cognitive development onto people through positive reinforcement, or obviously punishment, positive punishment. Okay, and this was obviously very unethical because you just can't be electrocuting people, right? Come on now, that's not good. All right, so that was an interesting study, I thought, too, and reading into it. Hopefully, you guys, when you looked at these experiments, you maybe looked into and dived into it a little bit more and grabbed some more information about it. 4, describe Humphrey's analysis of tea rooms broke many ethical boundaries. This one's a little out there, a little weird. What do you got, Hannah?
I said, in order to achieve this research methods had to be taken on similar playing fields, like 2 distance methods of research within the study. First, in order to gain a real understanding of the activity, they could adopt the method of
group observation.
Okay, all right. So what was the experiment about, though? What was this study about? You don't know? Sarah, what do you have for this?
Like, he was trying to compare, like, I guess people men who like went to tea rooms, like their home lives versus like, I guess it was just like a whole comparison thing. And he was kind of like, I thought that was the worst out of all of them personally.
Yeah.
He, like, was faking his identity to sneak in and then like gain their trust and then learn their personal information and then track them down, dressed up as someone else.
Weird
like,
stuff.
Multiple months later, and then get more information about them. So it's like part of it is like consensual because he's getting their permission for a survey, but part of it's also like the only reason I'm here is because I gained your identity through having a fake one and listening about your personal life, which is kind of creepy.
It is, yeah. And a lot of it was try to see with sexuality and how men interact in certain scenarios and different types of experiences with people. And it kind of got to the point, oh, it was a little weird and uncomfortable to read about. And he was like a stalker in a way. He was kind of getting people's license plate numbers, following them home, seeing how they would do things in their house. It was weird. It's really weird and very unethical, right? Very
Imagine
unethical.
like I'm just thinking about like imagine just so happening to read that like
What's that?
research. Imagine just so happening to read that research paper after it's published. You find this guy was like totally just like studying you the whole
Oh,
like
yeah.
knows everything about you and you had no idea. That's
Yeah.
like crazy.
Like faking identities and things like that. It's pretty crazy. It's pretty crazy. It's like something in a, like a, I don't even want to say like a villain in a comic book or something. It's crazy. It's like a show or a TV movie. I don't know, TV show or a movie. It's crazy. Yeah, so that one's definitely out there. Definitely kind of stalkerish. Like gives off a weird vibe of following people and faking identities to understand their, I guess you could say, their secrets, their deepest, darkest secrets, and some of their sexuality, their experiences. And, ugh, not good, not good. All right, we're going to move on from that one. So 5, what is Zimbardo's hypothesis, Stanford prison experiment? What do you got, Booker?
So human in the system wants the actions of the prisoner to really told or the prison situation.
Yeah, good job. So he wanted to see like the dynamics of a power struggle within prisons and how that kind of fell with prison guards, prisoners, superintendent of the prison. Okay, he wanted to see the dynamics of it and how it maybe affects some prisoners. Um, you watch movies, TV shows all the time with prisoners and how some of their rights were stripped from them. They're dehumanized by when they walk into prison. Some of their heads were shaved. They're really pretty much labeled by a number on their jacket, on their shirt. Okay, so they don't even have a name anymore. They're pretty much told anything what the prison guard would tell them to do. So perform different tasks. Their beds being taken away, food being taken away, maybe shoved into a dark corner, a dark area or room. And they just wanted to see the power struggle, I guess you could say, the power dynamics of prison guards and prisoners, and how that kind of fell with a scenario that he did at Stanford University. And this was done in the 70s. He's still alive today and gives different types of talks and discussion points on it, and how the study kind of went about and what he found with it. It's viewed as very unethical. And they actually have a movie on Netflix. I usually show it, but I don't know if I'll show it this year just because I want to try to get through the information. So if you want to on your own, check it out. It's on Netflix. It's called the Stanford Prison Experiment. I want to warn you, there's a lot of curse words in it. Sometimes it gets very uncomfortable, especially with some of the things that the prison guards make these prisoners do. And it's interesting, that's for sure. But it kind of falls on the lines as he actually didn't have an independent variable, right? He didn't have really anything interchangeable in his hypothesis, in his study. So that's why some people think, oh, this wasn't really actual study. This is almost like a simulation in a way of the prison. But he actually did gain a lot of information from it. He actually did gain a lot of insight from this study. And he actually had a person that was in prison in the 60s, 50s for very, very, I guess say a very terrible crime. So he actually asked him how this actually kind of unveils inside of a prison, how the how the prisoners actually react to some of the prison guards. And this guy was helping him set up the study, and it came to a point at the end, the actual prisoner who was helping him with the study said, "This is too much. This is terrible. This is exactly what I didn't want to happen with this study." And he just gets up and leaves. The study was supposed to last 2 weeks, and it didn't. Right? It didn't. It was, I think it was like 3 to 4 days or so. It just got way out of hand, to the point where Zimbardo even said, "Oh, I thought I was the actual superintendent. But I actually thought I was in the study. It actually tricked me." It's just crazy stuff. Crazy stuff. All right. Are there any questions on that? Any questions at all? So yeah, there's many more out there that follow some of these break these these ethical guidelines, and they're interesting to learn about. I think it's important to learn about it too. So if you ever are performing a study or experiment, make sure we think of ethics. All right, there we go. So moving on today, hopefully I can get through it. I'm gonna kind of just roll through it pretty quick, because statistics, you'll talk about this a lot, and a lot of this stuff you learn in middle school, right? And gathering data and how we represent it and show it within our studies. We just talked about ethics and research. I will give the experiment project, how about tomorrow? Okay, I know I said I'd do it today, but I'll give it to you tomorrow, and I'll let you work on it in class tomorrow. Does that work? Kind of a chill Friday. What do you think? Good stuff. And then if you have any questions, you can ask me about it, and I'll give the study guide out tomorrow as well, so you have that ready to go for the weekend and for the upcoming week. And we'll have a review on Monday. How about Tuesday test? Wednesday we'll do our project presentations. Does that sound good? All right, sounds good. All right, so here's some of the list. I'll just, there you go. You can find that in the presentation. Some of the experiments you can choose and you can pick. I kind of gave some of the examples already with the ethical, the ethics and research assignment. But if there's one on there or one that's not on there that you want to study a little bit more in detail, just let me know. Okay, just talk to me about it. All right, so using data for analysis, when we're representing our data, when we're showing our data, okay, frequency distribution, all right, obviously showing a summary of our information that we're gathering. So observations, it's data that we gather through our experiment that we can represent and show to the people that our study is proven, and here's the data that we've gotten, that we received. Okay, and this is going to help prove our hypothesis, right? This is going to help us through our experiment. Okay, again, you guys know all this stuff. You probably learned it through middle school and into high school a bit, I'm sure, through your math classes. But it's just reviewing with you some of the data how it's represented and shown in some of these studies. So with like a research paper, usually after you state your hypothesis, you go through your variables, you explain your experiment, you show and state your research. Then you give your results, you give your data at the end, you show them in these different types of frequency charts, pie graphs, histograms. You find the data and how it's mean, median, mode, right? Your average form of data depending on what you're studying, so on and so forth. That leads to the next thing, histogram. We all know that as our bar chart, okay, bar graph. And it's showing our frequency. Okay, and the height of the bars indicates frequency of groups and scores. And we all know the different axis of here, and how, in this case, number of employees and the salary in the thousands, depending on what age or what years of experience that you might have. Holy cow, 88 plus years of experience. Can you imagine that guy? Whew, that would be incredible. But anyway, we all know the histogram, okay, with a bar chart, a bar graph, expressing our data and showing our data. And it's needed for our research and to show the proof of our experiment. All right, mean, again, guys, this is very, very, very easy stuff here that you all should know, and I don't need to focus on too much. That's why I'm kind of rolling through it. We all know this as the average point, the average measure of our data. So the mean is the average. So the data that we're given, We add it all up, we divide it by the number of data points we have, and we find the average. We find the average. So this might be ages, right? This might be something that we're trying to find with ages in a group. It might be on a football team or something like that, or in school. We grab that information, we take note of all the ages we have, we add them all up, divide them by the total number of people, and we find our average. Median, we know that as a middle point. Usually we sort them in numerical order, and we find that median. Okay, sometimes we might have to take the average of a certain set of data to find the actual median of that information, of that data. So we all know what the median is. So we sort them all in order. Let's say their ages, 15, 16, 17, 18, 19, 20. We find the median of it, okay, and we can show it the middle number. Mode is the number that comes most prevalent. So let's say in the high school here, we might have more 17-year-olds, right? So the mode in that set of data would be 17 because there's more people that are 17. And we all know that. We all know that. So to test you real quick, let's go through it. Find mean, median, mode of these set of data here. So employees, salaries at McDonald's. Does anybody work at McDonald's here? No? Okay. I like the Shamrock Shakes. They're out. Anybody get one of those yet? Campbell, no? You're not a big Shamrock Shake girl. Oh. Don't you like mint? You don't like mint ice cream? Ooh, okay, okay. All right, so find the mean, median, mode. It shouldn't take you too long to do this. Just to make sure we have it, we know what we're doing here, and we can move on. Easy statistics here, right? Easy math. Sarah, do you like Shamrock Shakes? Oh, you never had one before?
I've had one, but I'm not like regularly.
No, I gotcha.
Yes, it tastes. It's just like a
Mint.
mid chip without opportunity.
Yeah, exactly. That's gonna mess up your running, so I get it. I get it. It's gonna slow you down.
Yeah.
Now that that snow's going away, you should be good to go, right? You should be able to run up that mountain, no problem.
So,
All right, we good? Do we need more time? I think we're good. Let's just move on here so we can get through this. All right, so what do we got for the mean, the average? What do we have? What do we have? Sarah, what do you got for the mean?
I added them all up and divided it and got 162.
You got it. Okay, when you round it up, yep, 162. Good work. Oh, sorry, median. What do we have for median? Booker, what do you got? 160. Good job. And then the mode. What is the mode? Campbell? 140. Good job. Easy stuff. We know that. All right, standard deviation. I won't have you do this. Don't worry about it, okay? I know you're itching to do it, right, Sarah?
You take AP Bio, you get to do it, and it's not very fun.
Oh, I hate it too. I hate it too. So I won't make you do it. Don't worry about it. Standard deviation is just really if you gather data, if you gather a different set of points, this is how far from the mean that data is, okay? How far from the average set of data points that you have and you have established and that you found, how spread out it is, okay? All right, so a low standard deviation means that these data points, this information, this data that you gathered is very close to the mean, right, to the average, all right? A high standard deviation means these data points are further away, okay? So this data might not be very correlated depending on what type of variables you're studying. So they're kind of scattered away. They're further apart from the mean. So low standard deviation, okay, it's closer towards that average, closer to the mean. High standard deviation means it's further away from that average set of data points, okay? And that correlation might be a little bit different than obviously when you're looking at it. So if there's variables that you're looking to correlate, you're trying to find that relationship. It might be further away. All right, here's just a graph to kind of represent that, to show it. So the mean right down the middle, that blue line. Okay, depending on the data points, standard deviation might be closer together, might be further away, depending on, obviously if it's a lower or higher standard deviation. All right, normal distribution, they call it the bell curve. All right, the bell curve. I'm sure you heard about this as well. So this is a normal distribution. Okay, a lot of the data points, a lot of the information is gathered here, right in the center, right smack dab in the middle. Okay, oh look, they're testing IQ scores. Oh boy, oh boy. I know I'd be right around in here, right towards the back end of it. I never took an IQ test, I don't think. Ugh, I'd fail that. But anyway, the bell curve right there, 68%. All right, that's usually the normal distribution center of a lot of the data points that you might gather. So if you have a normal distribution, let's just say number of the people that you're studying, the population is located in that area, that specific area. Let's say 70 to 130. That is a normal distribution. So you might have some outliers. Obviously, if someone like one person scores, let's say a 55 or less, or a 145 or higher, that'd be good. That'd be great. And that might be an outlier there. But for the most part, your data points are all pretty much average. They're right around that significant point. All right, skewed distribution. All right, skewed distribution with a positive skew means that there's a long tail in the positive direction. Okay, long tail in the positive direction. So this first distribution is viewed as a positive skew. A lot of that information, a lot of that data is gathered. It's shown. Okay, it shows that a lot of people may have scored in the right direction, and I might have a high IQ score that's kind of dwindling down towards the end, with maybe some outliers. A positive skew. Negative skew, okay, has a skew in a negative direction. Okay, when we talk about some different types of correlational charts, it might be a little bit different than this, but the negative skew shows how some data points, outliers, okay, might be out towards the left of the graph, moving towards the right, where you'll have a higher set of data points, a larger population focused on that information. We already know the normal distribution. They call it the bell curve just because it looks like a bell, right? And you have a lot of your average participants, a lot of your data residing right in the middle, okay? Kind of like an average score, if that makes sense. So a lot of the average score, let's say, I don't know, 90%, 85%, you score on a test, you'll find a lot of different participants, a lot of different people scoring around there. Okay, same thing with negative. It might be a negative curve. Let's say a lot of people did poorly on the test. Okay, you might have some higher scores right around there. Positive skew, same thing. Yeah, let's go with that. All right, so with this one, okay, this skewed distribution, I'm going to move forward just because we're running low on time. But real quick, a correlation is just the relationship between two variables. All right, relationship between two variables. So we all know a good correlation would probably be time spent, right, studying and our grades. Okay, so if these two variables, if our time spent studying is increased, if we spend, let's say, an hour studying, looking over our notes, our grade's most likely going to increase. So we're going to see a positive nature, a positive correlation, and those two variables are going to be closer together if people spend an hour, 40 minutes studying. A negative correlation, okay, obviously, with these two variables are further apart. They have a difference. And no correlation, these values brushing your teeth pertains to your test grades. I don't know, something along. I just made one on the top of my head. We all know that has no correlation. You're not looking over any type of material, right? You're not thinking. Well, you could be thinking about maybe some of the stuff. Do you think of psychology or anything like that when you're brushing your teeth, Sarah? No, yeah, exactly, right? So that's something that those two variables just don't make sense. The correlation coefficient is numbered between -1 and +1, expressing the degree of a relationship between the two variables. So real quick, I just want to show you a chart here that will help you with your activity today. Positive correlation, we'll see this as an upward slope, and depending on that correlation, if these variables are closer together, depending on if it's a +1, -1, these data points are going to fall closer to this line. Right? If they're further away, that means there's really not much of a correlation between the two variables. But a positive correlation, we see it rising in the upward direction. Okay, and these data points are following that line tighter together, showing that there is a positive correlation. That the variables do have a strong relationship to each other, depending on what you're studying with the y and x axis, obviously. All right. Negative correlation, okay, obviously this is something that has to do with a relationship between two variables. Maybe they don't have a correlation at all, right? Or they have a negative correlation, okay, pertaining to what it might be. So here's an example: education and years in jail. People who have more years of education tend to have fewer years in jail. Oh boy, right? So that might have a negative correlation. Okay, as represented here. All right, no correlation means that these data points, okay, depending on what your x and y axis are, your two variables, if they don't correlate, like that example I gave, brushing your teeth, and your test exam scores, they don't correlate at all, really, unless you're really thinking and you study while brushing your teeth, which I don't think anybody does. All right, that has no correlation. All right, so here's some examples of some of these correlations here. So positive correlation coefficients indicate a stronger connection as they get closer to 1. So as 1, +1 right there, we know that the data points pretty much fall along that line. We see no points kind of straggling away from that positive correlational line, right? As we move further away, when we get closer to 0, all right, when we get closer maybe to -1, these points kind of pull away from that correlational line, as you can see. So once we move down 0.05, there's like really no correlation between those two variables. It's kind of scattered all around the data points. Okay. All right, so let me just see if that's it. Yeah, that's it. That's it. So let me assign the activity for today so you can work on it. It's just about correlations. That's it. And I'm sure you all know mean, median, mode. That's why I did that quick example with you right there in class. So if there is a question up on the test or something like that, you know how to do it. All right, so I'm going to post that. There you go. We did come to the end of the chapter, meaning we will probably have a test here in the near future, and I think I said Tuesday. So I'm going to have the study guide out tomorrow along with the research project experiment, or experiment.